All right, guys, welcome back. Today we're going to wrap up rational expressions and equations and inequalities. We're going to wrap up the rationals with our favorite skill, which is word problems. Okay. The good news, we're going to use tables. Okay, we're going to use tables. Remember how we did tables for distance? How we used the table? We did rate times time equals distance. Remember, and we do the little table like that? We're going to use the exact same table, except if you think about it, guys, rate times time not only gives you distance, but it actually gives you the work that was done. Because when you're in a car or in a bike or just walking and you are moving, aren't you having moving parts move your body, whether it be your legs or the wheels of a tire of a bike or of a motorcycle or of a car? Isn't there work being done? So WD we're going to call work done. Work done equals rate times time. Remember that, guys, and remember how to manipulate it. So if I want to solve for time alone, time will equal work done divided by the rate. If I want to find the rate alone, the rate equals work done divided by time. So the one thing we want to remember here, that's why I changed my lecture. I said this makes it a lot easier for them because it transitions from distance to work done. So instead of me just teaching you a crazy brand new skill, a whole different way to think, no, that's bad. Let's keep it on the same plane that we've already been learning, okay? Remember that the goal of any equation, of course, regardless of difficulty, is always the same. Solve for the variable in question by isolating the variable. We know that part already. Let's go ahead and read this, guys, and we'll go by the steps. And I changed the steps, like I said, a little bit from what your PDF is. It's Saturday and Kevin needs to cut and edge the grass. At 9 a.m., Michael asks Kevin to go golfing at 11 a.m. Typically, it takes Kevin 3 hours to cut and edge the grass. When Michael cuts and edges the grass, it takes 4 hours. If they work together, would they be able to finish the lawn and still make the golfing date? Okay, this is a work problem. Your first step, identify what you are solving for. We are solving for the time it takes for both of them to cut the lawn, correct? Okay. And in this case, yeah, we want to find how long it will take Michael and Kevin to finish cutting and edging the grass if they work together. Step 2, define the variable you're going to solve for. Aren't we looking for the time that it takes for them to cut it together? So time is the variable here. In this, not if this case, but in this case, let T represent the time in hours that it takes to cut and edge the grass while working together. And then step 3, write a rational expression using the following logic. Since Kevin can finish the job in 3 hours, he will finish the job in 1/3 of T hours. Okay? Michael can finish the job in 4 hours, so Michael will finish in 1/4 of the job in T hours. So what's happening here is, basically, if I can finish something in 5 hours, don't I finish 1/5 of the job in 1 hour? If I can complete something in 20 hours, don't I complete 1/20th of the job in 1 hour? Does that make sense, guys? The concept, what I'm trying to say here? Okay, let's put it now in actual computation because I know it's going to make it a lot easier. Okay, so it's, okay, and you know what? I should change this. It shouldn't be 1/3 of the job in T hours. Well, yeah, it should. Yeah, I'm right. Okay, so I have here part done by Kevin in 1 hour, part done by Michael in 1 hour, and the part done together to equal one complete job. Okay, so what's happening here is the part that, who was it, Kevin or Michael? Who does it in 3 hours? Kevin. Okay, Kevin's part plus Michael's part gives me one complete job. Michael's part plus Kevin's part gives me one complete job. You look a little bit weird there. Talk to me. I'm here to help. You should. This will flow a little bit, okay? So let's use our table, my brothers. We've got Kevin and we got Michael. They told us from the beginning, they said that it takes Kevin 3 hours. Whoa, that's weird. It takes Kevin 3 hours, okay, to cut and edge the grass. Kevin's 3 hours. So that's how I came up with the rate for Kevin is 1/3. Because in total it takes him 3 hours, then in 1 hour he'll do 1/3 of the job. Does that make sense? Promise? Mike takes 5 hours to cut and edge the grass. So that means in 1 hour he's done 1/5 of the job. Well, it was 4 hours? I apologize. Sorry, thank you. 4 hours, so it's 1/4 of the job. When they're working together, guys, do we know how long they're working together for? So we can call time T. You with me so far? Yeah. What's the work done for Kevin? Doesn't work done equal rate times time? So T over 3, that's where I got that bad boy. What's the work done for Mike? Remember, rate times time, numerator times numerator, denominator times denominator, T over 4. So I have Kevin's plus Mike's to give me one complete job. Now in this case, this one's Mickey Mouse, okay? Here you're going to multiply everything by 12, so I'm going to get 4t plus 3t equals 12. So I got 7t equals 12. T equals 12 sevenths, which is 1 5/7 of a minute. Of an hour, I'm sorry. Minutes in the next problem. And that's how we do that. Does that make sense? Talk to me. This is all we're going to do today is examples. Okay? Now, I know it's small here on the screen, but you have the notes right in front of you. Anything that's like totally, it just went over my head, Mr. Morrow. If it's I kind of get it, that's okay. But is anyone like completely lost, like they have no idea what I'm talking about? Awesome. May I continue is the next question. Thank you, gentlemen. Yeah, Papa. How do I calculate the up a little bit? Part done by Kevin. Okay, thank you, Papa. Doesn't it correct? So isn't that 1/3 of the job in 1 hour? Thank you, my brother. Thank you. Okay, don't stress. It gets crazy, okay? These word problems are crazy. I'm going to tell you the truth. When I was your age, oh my God, I hated these, dude. Like, I hated them with a passion because they taught me a different way, and that was the way I was going to teach you. And I started thinking about it, and I was like, this is not going to work. This is not a good method. So this method is a lot better. Remember, right from the beginning, we got rate, time, work done. John and Sally have a pool in their backyard. If they use their hose alone to fill the pool can be filled in 30 hours. So if they use their hose alone, the pool can be filled in 30 hours. So what will their rate be in 1 hour? 1/30th, right? You with me, guys? Now, the neighbor has the same pool, same size, and was able to fill it in 24 hours. So the neighbor alone, the neighbor by himself, will finish 1/24 of the job in 1 hour. Now, if I take both of these together, they're going to fill the pool as well. Do I know how long it's going to take to fill the pool, though? So that's T and that's T, because they're both going to be working the same amount of time, right? Both hoses turn on together and start filling up together. Is that the logic there, guys? Okay, so what's the work done by John and Sally's hose alone? Yeah, don't be scared. T/30. Good. What is the neighbor's work done? T over 24. What is the time that will take to fill the pool when we use both of them together? Well, T over 30 plus the neighbor's T over 24. How long will that take to create one complete job? Yes. That's what I'm talking about. Good job, guys. I would say, what, 240 is the LCD? I'm just thinking that off the top of my head, right? 240? Or would it be 120? Be 120, right? Yeah. 120 would be easier. So I'm going to multiply 120 to everything, my brothers. 120t divided by 30, we're talking about 4t. And then plus 5t equals 120. So this is 9t equals 120 divided by 9. T will equal, you got one, let me just do it out. 1, 9, 30. It's going to be 13.3, right? Right? Is that right? So T got 27, and then I got the 3. Yeah. So this is going to be, T will be 13 and 1/3 of an hour. That's how long it's going to take them to fill the pool using both hoses. Talk to me, bro. It just clicked? Nice. Good. What else, guys? Because we got plenty of time, and I still have a couple more examples. So, but I want to make sure you guys are understanding this. Yes? It's good? Okay. Next example. Bless you, son. Suppose that the kitchen sink can be filled in 5 minutes. Whoa, sorry, guys. If the sink is full, it takes 8 minutes to drain the sink when the drain is left partially open. If the sink's drain is accidentally left partially open, how long will, where did I learn how to write? I put will T take. And will T take, that's not English. How long will it take to fill the sink? Sorry, guys. Thank God I'm a math teacher and not an English teacher, right? All right. So let's make our table. Rate, time, work done. Okay. So suppose that, so you can fill it in 5 minutes. So how much of the job is done in 1 minute? 1/5. Good job, guys. Yeah, I know. I just, hold on. Okay, fill, drain. So fill, you can fill it in 1/5, or 1/5 of a minute, right? That's, you can do a whole job in 5 minutes, so the rate is 1/5 in 1 minute. The time, we have no idea yet. Drain it, we can drain it in 1/8, right? Because it drains in 8 minutes, so in 1 minute you'll complete 1/8 of that job. We don't know how long it's going to take to fill it up. But here's the trick here, guys. What's the fill work done? T over 5, very good. Now, what's the drain work done? Negative T over 8. All right? I didn't put a negative in the beginning, and I know I didn't. I wasn't trying to hurt you. But you guys got to use logic, and I know you got it. You just got to read and be careful. Focus. If I'm draining something, am I not taking away water at the same time as it's filling? So the fill work plus the drain work, when will that give me one complete job? When will that give me one full sink? Same exact thing as always. This time we're going to multiply everything by, bam. So I got 8t minus 5t equals 40. So 3t equals 40. So t equals 12? No, 13. 13 and 1/3 minutes. And if you think about it, guys, does that make sense? Will it take longer to fill if I'm also draining at the same time? That's where sense has to be made of it. Talk to me, Papa. Talk to me. You got it now, though? Okay. Thank you, bro. Thank you. Now, I want to get into distance and motion as well. Actually, let me do a distance and motion one first, and then I'm going to show you another one that's a little, not tricky, but just something different in the work problems. Actually, you know what? We're still on work, so let me stick to work. Let me, I'm gonna give you guys one, and I'm sorry, I know I didn't put it on, your actual PDF, and I apologize. So bear with me. It will be on the video though. Let's see, which one did I want to do? Yes. Okay, let's say I have this, guys. A train required 2 hours longer, okay, to travel 500 kilometers than a plane required to travel 1,200 kilometers. Find the speed of the train if the plane travels 4 times as fast as the train. And this is all nice, but this isn't the one that I wanted. Isn't that awesome? Yeah, let's still write it, yeah. This is not a work problem, though. This is a distance problem, but I wanted to show you a tough distance problem. Then I'll show you the easy distance problem, and then I'll go back, and here's the right one that I wanted. Yeah, I know. That's another distance one, Pablo. Thank you, my brother. I really, really appreciate that. Thank you very much. Okay. So let's look at this problem right here real quick, guys. Let's look at this problem right here real quick. In this case, we're talking about a distance problem, okay? But it's going to be a little bit nasty. That's why I wanted to do this. It's going to be a little bit nasty. You're going to have to use rational skills. We're talking about distance, so of course, rate times time equals distance in this case, not work done. It's distance. So we're talking about a train and a plane. A train required 2 hours longer to travel 500 kilometers than a plane required to travel 1,200. So what is the plane's speed? X. No, the plane is X. The train required 2 hours longer than the plane. So the train is X plus 2. The distance of the train, 500. The distance of the plane, 1,200, right? Okay, you guys with me so far? Now, this is the temptation for most people, and this is where everyone just crumbles. And this is normal. They say, okay, what do we call rate? And some people will put an R and an R. That's wrong because you can't have the same rate, first of all. They're going at different rates. And then what happens on top of that is now you have a system of inequalities. So that's a mission. So what you're going to do is use the formula that I said before. Doesn't rate equal distance divided by time? So this rate is going to be 500 over x plus 2. This rate is going to be 1,200 over x. Are you guys with me so far? You sure? You guys want to write it down? What, Bubble? Yeah, the plane travels 4 times as fast. If you want, I'm going to show you how to set it up if you just use that part. Watch, trust me. You'll see what I mean now. Does everyone understand what I got here? Okay. So then what are they trying to find here? We're trying to solve for wait, why would I set that equal to each other? So wait, when is this? So, longer to travel 500. Right, okay. Okay, Danny, the question you asked that I ignored was the part that I was missing here. Doesn't it say that the plane, isn't the plane 1200 over x? If the plane travels 4 times as fast as the train, find the t. Find the time. Do you see what I did there? The plane, which is this, travels 4 times as fast as the train. So the plane, 12 over x, is 4 times as fast as the train's rate. Does that make sense? Somewhat. Where does it not? So I can help you. Thank you for your honesty. We know that the rate, the speed of the plane is this, right, Papo? So that I just put here. You with me so far? Didn't they say, bro, that the plane travels 4 times as fast as the train? What is the speed of the train? Isn't it 4 times faster than that? Does that help? Promise? Okay, now, guys, this is the part that I know you're not going to like, but now we got to solve this, okay? So this is going to be 1200 over x equals 2000 over x plus 2. Okay, guys, we know how to do this. You could do one of two things. You can cross multiply this bad boy, or multiply both sides by x times x plus 2. What do you want to do? I don't care. Okay, so let's multiply x times x plus 2 to everything. So when I multiply to this, the x is canceled, so I'm going to have 1200x plus 2400 equals, these guys cancel, 2000x. So when I subtract, 2400 equals 800x divided by 800, x equals 3 hours. Okay, now, what were they looking for, though? They want to find the speed, okay? So now we're going to plug this in. We got to plug in the x is 3. So what's 500 divided by 5? 100, guys. So the train travels 100 miles per hour, or kilometers per hour, whatever it is. Is it kilometers? Yeah. It's kilometers. And the plane, 1200 divided by 3 would be, and then again, does this make sense? Yes, because doesn't the plane have to be 4 times as fast as the train? Does that make sense, guys? Promise? All right, we're going to do one more, and then if I have time, I'm going to do a funky work problem. If not, you'll see the funky work problems over the homework, and then you'll ask me tomorrow, worst case. Yes, Pablo?
Which quiz is this?
This is going to be the quiz on Friday, sir. Okay, so you have a couple days. No, this is not a take-home quiz. Okay? All right. Now, how about this one, guys? A plane flies 990 miles west into the wind. Into the wind. Remember that. Remember we have the whole wind thing. Rate times time equals distance. And makes a return trip following the same path. The effect of the wind on the plane is 20 miles per hour. The round trip takes 10 hours. What is the speed of the plane in still air? Okay, so we're going to, and then we're going to return. Okay, so this is a plane flies 990 miles west. So 990 miles is my distance. Into the wind. So into the wind, is that against? Against, right? Okay. Very good. So the rate, we have no idea, and it's going against the wind, right? The effect on the plane, actually, is 20 miles per hour. So the wind is 20. So R minus 20. On the return trip, it's 990 miles again. But this time, you're adding 20. It's a tailwind. It's going to speed up your trip. The round trip takes 10 hours. So we'll call this x, and we'll call this 10 minus x. Please tell me you remember that, guys. Yeah? Okay. Now, we got to set them both equal to each other. So, uh, wait a second. Oh, I'm so silly today. So rate times time, r minus 20 times x has to equal r plus 20 times 10 minus x. So this is going to be xr minus 20x equals 10r. Wait a second. What am I doing wrong here, man? Okay. All right, guys. A little bit of a brain fart here. We have two variables, so we're going to have to set up a system of equations. So we've got xr minus 20x. Yeah, I know you guys are real sad about that. We'll finish this one up tomorrow. The homework is valid, though. Give me 1 second.